Welcome. Before I go running today, just a short video about one of the problems, true-false problems we have seen in the final exam. I graded until yesterday and it was well solved, the final exam, and I'm very happy with what you have learned. But there was this problem true false 2, which was a little bit difficult. You might remember the problem. So there were the question was where you have two spheres and you have the question is whether and the third point, whether the distance from the point to the sum of the distances of the point to the spheres is larger or equal than the distance between the two spheres. Makes sense, but we have seen similar problems like with 3 spheres where it was wrong, or 3 lines where it was wrong, 3 planes where it is wrong. And so I once told, even in office hours, in general, if you see an inequality which is, you have never seen, it's probably wrong. And but when I wrote the exam, I had a little bit of a also fun with being creative, and I looked at the problem then with the 2 spheres and the point, and actually there it's true. So the distance now, this distance inequality holds. I will make an exhibit about this, but you can ask this question for all kind of different shapes. So you can ask it for, you have two cups like that. Is it true that the distance and the point, is it true that the distance from a point is to the sum of the distances to the 2 objects is larger or equal than the distance between the two objects? And the distance between the 2 objects is always the smallest distance you can kind of find between 2 points, where one point is on one object and the other point is on the other object. So it can be asked for many different things. It can be asked for cylinders or parts of cylinders like these 2 beams here, or rectangular regions like this. You have 2 rectangular regions, and then you can ask this type of question. And you might remember also that at the very beginning of the course we have looked at Polya, and we have looked at the problem of how many different regions, planes divide space. And so it's a very interesting problem which can be generalized in many different other contexts. And the point of Polya is to the ability to kind of illustrate the ability of asking good questions. So that's one of the most important things for the mathematician should be able to do: ask good questions and explore things and see where is it true, where is it false, make hypotheses and then try to prove it and disprove it, and so on. So that's that book, and the video is also on the website about Polyas' lecture on this plane problem. There are other books which this is one of the books, but also explaining a little bit. It's very interesting explaining how people get ideas and how people explore in science new ideas, and how mind works in finding this. It's all techniques, and so these techniques can be also studied kind of on a meta level. So that's a very interesting thing, and I ask you to just explore that maybe a little bit, that question. You take 2 objects or 3 objects like these 3 stones here. Is it true, if you take 3 stones, that the sum of the distances between one stone and the other 2 is bigger or equal than the distance between this? So in this case we have seen already for spheres it's actually false. So but is it true if this stone is now just a point? And so these are very interesting questions, and some of them are not yet explored. Okay, now I'm going running.